So my presentation is centered about the analysis of a supply chain for a pharmaceutical company, a French pharmaceutical company. The analysis was made in order to make the right support for the launch of a new product that we call drug. And this launch is a worldwide launch that is going to have in these days. The study was started in 2020. So, let me show my presentation. Okay. Okay, the title of the presentation is a supply chain analysis for a pharmaceutical company. As I told you before, this is addresses the study made for a small medium company, French company, a pharmaceutical company. And the main objective of the supply chain studies are listed here in the slides. First of all, the analysis of the stock policy in order to have an appropriate trade-off balance between financial cost and service level. The second objective was to make the supply chain as robust and resilient as possible in order to have, the ability to face and to tackle with some disruptive events. The third objective was the cost saving, of course. This is a typical objective that we can find on every supply chain. And of course, also the last one, ensuring a high level. I acted as a consultant in a team of a consulting company, where the consulting company was involved in several aspects of the supply chain, which means, preparing the contract, making the memorandum of understanding, and preparing the contract for the CMOs, for contract manufacturers, and so on. The study was accomplished also by using anyLogistix, that was strictly probably the best tool that we could use in this case. And this is also the tool that I use at my university, the Catholic University of Milan, where I teach business system strategies and business dynamics, which is a course at a master. So let me say, first of all, that the company we are talking about didn't own and doesn't own any manufacturing infrastructures, in the sense that they don't produce, they just produce research. And except some case, a very simple case. In this case, they decided to not to own the manufacturing infrastructures, taking into account that the production volume needed in order to face the worldwide launch of this product were very high. And so they already identified the partners involved in the supply chain, which were the company where they already had been receiving their support from this company. So the companies are another French company, producing the active principle, the so-called API. An Italian company producing the semi-finished product and the finished product as well. This is in Europe, in the United States, for serving North American market, both for United States and Canada, in China and in Japan. And at least, last but not the last, last but not the least, in this case, a logistics service provided, which was located in Italy, very close to the airport, ready to launch, to deliver the product worldwide. So we use anyLogistix, and in particular, anyLogistix for the simulation. we didn't need to make some optimization, taking into account that I mean the places and the location were already identified. And then we use anyLogistix just for simulate possible scenarios that we see in the next phase of the presentation. So this is the structure of the supply chain. We start for the French company, which produced the primary producer that produce the bulk. This is called bulk. Bulk is the, as I said before, the API, the active principle. The active principle is delivered to an Italian company, which has which pays the bulk on bulk inventory located in northern Italy. And this bulk is used by the manufacturing, the contract manufacturer located in Italy also, that produce at first the semi-finished good. I mean, transform the bulk, which is a sort of a powder, in several pills, and then make also the packaging. So semi-finished product is the pill, and final product is the case that contain bottles or blisters that on turn contain pills. So as you can see, the factory, Italian factory, will we give and deliver its product to the European DC, which is located at the LSP location, the logistics service provider location, based in northern Italy as well. And also deliver to the same logistics service provider the right amount to send, to deliver the messages, to deliver the final product to the finished product to the 3 different DCs, distribution centers located in North America, in China, and in Japan. This is by and large, you see the number of pills in the period. The period taken into account is the launch from 2024 up to 2031, and you can see what I mean, the order of magnitude of the number of pill in terms of medium that they have to produce and distribute. So this is the demand forecast for the 4 markets indicating North America, Europe, China, and Japan. And you see what I mean, the magnitude, or I mean, the amount of pill that have to be distributed starting from 2024 up to 31. And this is the baseline, of course, the so-called baseline forecast. And you see the number of, in terms of million, the number of pills in millions that have to be distributed, delivered to the DCs. The offer includes 2 different finished products, as I said before, a box of 28 blistered pills, in particular for EU, China, Japan markets. Instead, for North American market, the bottles, well, I mean, the SKU is bottle of 30 pills. So this is the production structure. You see, well, you know, this is the production flow. So you see the raw materials needed to produce the bulk. The bulk manufactured at a French company. So from the bulk, we obtain the pill, we get the pills. The pills, you know, are transformed in, you know, are bottled in bottles. 1 bottle's 30 pills, and in blisters, 1 blister, 7 pills. On turn, blisters, you know, 4 blisters make a case, a box case. Okay. This is in terms of commercial, you know, this is the product, the one that we saw before, it was the products flow. This is the commercial flow. So from the bottles in terms of the logistic deliveries are put in a carton in pallets, and the same, of course, for blisters, as you can see. So this the final production scheme. So we start from raw material, prime manufacturing in France that produces bulk. The bulk is used by the second manufacturer located in Italy that make both the semi-finished product and the finished products. At the end, produce bottle and blisters, as I said. In particular, in terms of phases, this is important because we have to use extension in anyLogistix in order to better represent these process steps. In particular, to produce semi-finished products, well, I mean, the process is based on granulation, blending, tableting, coating, which are the main steps to produce pill. And then in terms of, finished product, as far as the finished product is concerned, the pills has to be put in bottles and or in blisters, well accompanied by the quality assurance, the quality investigation. This is a value stream mapping in terms of some technical components related to each step of production, batch size, batch cycle time, and capacity. And the total throughput time is 155 days around. In terms of, and this is an important part, in terms of inventory policies, so stock policies in general, well, I mean, the bulk is ordered through a make-to-order approach. The reorder of the bulk from the Italian company is based on a reorder quantity with safety stock. Instead, well, I mean, the warehouse of the inventory of the European market and the Italian factory, Italian finished product factories, and the DCs, the different DC, the stock policy for them is based on an MRP policy. Let me say the MRP in terms of anyLogistix, what anyLogistix calls MRP, which is contain, well, I mean, all the drivers that make it possible to organize and make it possible to organize an MRP like policy. This is the transportation, the freight transportation. We have air freight transportation from Italy to the different DCs located overseas, worldwide. Instead, the European market is served through a DC located in Italy, as I said before, and served through a truck. So we have trucks and air freight transportation, road transportation, and air freight transportation. This well, I mean, some technical data. I don't spend so much time. Well, I mean, for instance, we have 3 days from the transit point to the overseas market, and you see 1 day for what I mean, the DC customers. These are the speeds necessary to reproduce in anyLogistix the right simulation, the right digital twin, and the cost are computed per kilo in terms of truck, if we use truck as a vehicle. And for air cargo, as far as air cargo is concerned, the costs are computed as cost per trip, in euros per trip, which are different, of course, for each destination. In terms of cost, the main cost that we have to take into account, we see the production cost, the warehousing cost, which reflect the cost for renting the space for stocking goods. The inbound and outbound logistics costs, means the operations cost for, what I mean, all the operation in the warehouses, the DC, and eventually the transportation cost, as I told you before. These are the 4 main cost that we have. And as you see in these slides, well, I mean, the transportation cost is not particular, significant, meaningful in terms of, well, I mean, the way in the profit and loss sheet. Instead, the production cost, particularly the production cost of the bulk, which is the matter, the good more expensive. And you see an example here for the baseline scenario. And you have to compare these two figures here. So what I mean is 1/10 transportation costs are 1/10 with respect to the production cost. So in order to be more practical, you see that we prepare different simulation cases, different experiments, if you prefer. Case one is the analysis of what happened by changing the inventory policy, so an inventory policy variation analysis. The case two is bulk batch size variation analysis. The case three is risk analysis, so disruptive risk simulation. And case four is demand variation analysis by changing, the baseline by building both a best scenario and a worst scenario starting from the baseline. Now here, for reason of time, of course, I just prepare the bulk inventory policy variation. And the bulk inventory policy variation is very important, probably is the most important experiments in terms of cost and then in terms of impact, its impact on the profit and loss sheet, because the analysis of the inventory policy is has a high impact, especially in the Italian bulk inventory, because they have to transform the bulk in the pills by respecting the service level, and then also by respecting the value time that we have seen in the value stream mapping. So in this case, we consider 9 scenarios by changing. Let me say, first of all, that we use reorder point-based inventory policy, and so that is well feasible in through anyLogistix. We use safety stock, desired inventory level, and the minimum inventory level. So the order quantity is the sum. The trigger is the sum. The replenishment point is the sum of S plus double S. Double S is the safety stock. S is the minimum stock. Instead, the reorder quantity is capital S plus double S. And so you can see in this matrix the combination of, by using different values of these 3 parameters, combined cross with the initial quantity. So in terms of kilograms, so an initial quantity of 1,000 kilograms, 2 is 500 kilograms, and 3 is 0 kilograms. So by combining this situation, we get these 9 scenarios. So this is the simulation. This is what the simulation produced. I will show you also on the through anyLogistix, and you see that this activity, these experiments are started in terms of fulfillment, by production, this inventory, mean lead time, and industrial cost, and gross margin as well. So this is the financial overview. We prove it by taking into account the different scenarios that we name A1, A2, A3, and so on, up to C3. And you also see the inventory cost level. So in terms of, best scenario, the best scenario, B1 is this one that I'm going to indicate here. Is the baseline scenarios, and the best one that we identify is the profit, which the best profit is the A1 scenario. let me show the example by using anyLogistix, where you can see this is the B1, the scenarios B1, which is the baseline scenario. And in terms of, well, we know there are several indicators, KPI, that have been studied. And in particular, you see the financial aspects, which are, well, I mean, the ones that we also take into account. And by changing, well, I mean, the results, and as you can see, we can get, well, I mean, good improvements in terms of cost, where you see we lower the total cost, the production cost in particular, to 26 million. And in particular, this is could be you know, represented very well by taking into account the bulk inventory as both finished producer in Italy and the bulk producer in France. You can see here, you know, this is the analysis of the stock. You can see the comparison. B1 is the baseline scenario. A1 instead is the A1 scenario. As you can see, well, I mean, the amount of bulk, which is very expensive, is still limited. And the same thing happens for the producer, the bulk producer, where you can see, you know, the inventory, the available inventory in the case of the E1 scenario is definitely low with respect, lower than respect, well, I mean, the baseline case. Let me show, well, I mean, the number of, you know, tables that we use: bill of material, customer, disease, demand forecast also, because I told you that we use MRP, and so we have to take into account also this factor: facility expenses, group, inventory rules, and so on. And in particular, I just want to see you that we use as a type, you can see, you can recognize for those experts that, what I mean, can recognize this aspect. We also use extended library, and we create, you know, a special based on anyLogic. anyLogic is the software that makes simulation through which it's possible to build the simulation models. And you can see that we use, you know, unknown name and well undefined name that we represent the API, the library used as an extension. So let me say that we also study, I don't have time to show you, but we also study, well, I mean, the impact of using low volumes in terms of bulk. And so we make the risk analysis, and except some case where we had, well, I mean, a decrease of possible fulfillment. In general, the A1 scenario is a good scenario, and taking into account, well, I mean, that the fact that this is launch, especially in the first years of the launch, the company decided to use this approach, so A1 approach, instead of the safer but more expensive B. So that's all, guys.